So we're in 13.3, and I'm going to do a problem like number 21 and 23. Find the curvature of, and then we're given our r of t, or the vector function, t in the I component, t squared in the j, in e of t, or it should, well, either way, but e to the t, in the k component. So you have two choices for the curvature out of the ones that you're going to be given anyway. And it turns out this one is the best one to use here when we're not asked to find things like the unit normal vector, etc., etc. So if we're starting from scratch with the vector function, then this is the best thing to do. So first of all, before we start plugging in, notice that we're dealing with a derivative and the second derivative. So let's do a little side work before we plug in. It's not too bad here. Taking this derivative, term by term, we're just going to have 1 for the x component, 2t for our y, and then e to the t for our z, or the k. Then the second derivative from that is just going to be 0 to e to the t. So the next thing here, we need to find the cross product. So I'm going to do that as side work as well. And then we'll find the magnitude of that. So I have my ijk, and then I have 1, 2t, e to the t, 0 to e to the t. Find the determinant of that. Alrighty, so then I'm going to have 2t e to the t, and then minus 2e to the t times I. Then it's going to be minus, and for the j I'm going to have e to the t minus 0. So that one was not too bad. Plus, and then for my k, I'm going to have 2 minus 0 times k. So there we go. Now we need to find the magnitude of that. I'm going to keep going as side work, and then we'll eventually plug that into the curvature formula. Alright, so what do we got here? Root. And then thinking ahead here, I'm going to write this 2 e to the t factored out from the t minus 1, that quantity squared. Then I'm going to have plus e to the 2t when I square negative e to the t, and then plus 4. See if this boils down a bit. So I can square here, I'm going to have 4 e to the 2t, and then we have our t minus 1 squared, plus e to 2t plus 4. Okay, so that's probably good enough for now. Maybe something will materialize after I do the denominator there. So here we just had our derivative of r, the magnitude of that. So we found that up here. Let's just work on that for a bit. So we're going to have 1 squared plus 4t squared plus e to the 2t. Root that. And that's about it there. Probably not really even necessary to rewrite that, but I did. And so now let's finally put this all together. So where I got 2 for the cross product's magnitude of the first and second derivative of the vector function, just rolls off your tongue, is root 4e to the 2t t minus 1 squared plus e to the 2t plus 4. Kind of seemed like that might simplify more, but decided to kind of leave it be till we saw what the denominator ended up being. So there we have 1 plus 4t squared and what was the rest of it? Oh, plus e to the 2t. Okay, so now is the time that we can start. Oh wait, I almost forgot something. I almost forgot to take the third power. That's important. Okay, so now this thing is looking, I can start looking at this and seeing if I can simplify. Otherwise, if I can't, it's pretty much the answer. So some things to notice is I do have a square root, and I can maybe combine some of these, or at least one of the roots, because I got 3 of these times each other. So looking at this, there's some similarities, but it's not going to simplify any further actually, and not really too much of a bother to make about this, but I did notice the e to the 2t sometimes it's considered more simplified to take that out. I don't know, but then I got the 4 there. This is good enough. Okay, but you might have a slightly different answer than that, and that would be cool too. So probably should FOIL that out. Yeah, that's what I should do, but I'm gonna, this is good enough. Alright, let me just double check my answer.